Good morning. Today we're going to start with elimination method right in the middle of the packet. So this one's kind of weird because there's just kind of weird things that seem to jump in out of nowhere. So our warm-up today is to manipulate the equations so that each equation has a 10x as its initial term. So we are still using our math properties, but we're not solving for a variable. We're making our x term to be a 10x, and this will be helpful for this method. So in our first one here, if we want to get 2 to be 10 and we want to keep everything equivalent, we can multiply everything by 5. We do the same to both sides. That way 5 times 2x is 10x. That's what we wanted. And then everything else still gets affected. So we have 5 times y is a positive 5y. And whatever we do to one side, we do to the other. So 5 times 10 is 50, and it's set up ready to go. Our next one here, our goal is to get a negative 5 to be a 10x. Now we can do this in 2 steps, but I'm going to show you in 1 because I feel like we can handle this. All right, so we are going to multiply both sides. And conveniently for this one, 5 times 2 is 10. Oh, look, the problem number. Okay, so 5 times 2 is 10. However, we only multiply by 2, it's going to be a negative 10x, and that's not what we want. So to get that negative to become a positive, we multiply by a negative 2. So that way, negative 2 times a negative 5x makes a positive 10x. That's what we wanted. Then negative 2 times a positive 2y is a negative 4y, and 6 times negative 2 is negative 12, and it's ready to go. Final one gets a little bit trickier. I'm going to do this in 2 steps. You could technically do it in 1, but I know a lot of students are not ready for that. Okay, here we go. First things first, let's get rid of our fractions, shall we? To get rid of those divide by 5s, we multiply both sides by that denominator of 5. That way, the 5s are gone. We are left with 2x. The 5s are gone plus y. And 5 times 2 is 10, right? So we distributed to each term. From here, we have to go one more step because 2 is not 10. But to get 2 to be 10, we can multiply both sides by 5, as long as we do the same to both sides. 5 times 2 is 10, and 5 times y is, x, almost forgot that. 5y equals 50. Now, some of you are like, Miss Iceberg, if I could see that if I multiplied my 2/5 times 25, I could get there immediately, then do it. But I'm more of a 2-stepper on those anyway, so. But yes, 25, if you did that at first, you would have been done with both. Okay, so here we go. On the top and bottom row, make the coefficients both the same. That is key. Coefficients have to be the same. That sounds weird, but opposite. Yeah, I don't know why they missed that. Oh, here we go. Get 1 plus 1, the other minus. There you go. So yeah, we want the coefficients the same, but opposite. That's what this part says. Get 1 plus the other minus. So we want the numbers the same, but opposite signs. Those are the rules of this game. Because what happens when you have the same number that are opposites, like you have 10 and negative 10, you got 10 cookies, you eat 10 cookies, you got no more cookies. So they've been eliminated, hence the elimination method. So the first thing on the top and bottom row, we need to line up our variables. So see how we have x's here and y's here and then our constants over here? That's what we want. So standard form is actually preferred for this method. So your goal could be to get them into standard form. Here, standard form. Good. So now they did it a little bit more complicated than I'd like to. Because as we talked about a little bit in class, as you were hearing, choose the easiest route. There is actually an easier route with this that deals with smaller numbers, but we'll just follow what they do, okay? So our goal is to get our coefficients the same. So what they're doing here is they went to get 9 and 3 together. You could have done that and gotten 27, or you could have done even better, get your 3 times 3 to give us 9. Perfect. That would be the ideal version. But they didn't go for the x coefficients the same. They went for the y's. Do you see how they made them both 24s? How would they make them 24s? Oh, great question. 4 times 6. So they did the top one by 6. So they multiplied everything in here by 6. So 6 times 12 would give us 72. 6 times 4y would give us our 24y. And 6 times 9 is 54. Now those seem like giant numbers. Yes, they kind of are. And then our bottom one here, we want them to get to be the same. 4 and 6 can both go into 24. I don't know why we didn't do 12. Not up to me. Again, I found 2 easier ways now. So 6 times 4. 6 times 4 would give us that 24 down here. That way we have the same coefficients for the y's. Cool. But everything else still gets affected. So that 4 still gets multiplied to this -3. And these, I guess I could put the parentheses there because technically it is going by all of them. So 4 times -3 is -12. We already did our 4 times 6. And 4 times 3 is 12 up here. So as you can see, some of those combinations, we could have used 12 here. We could have used 9 for our x's. There's some simpler ways. Our next piece is to make sure they're opposites. Now, if you can, get them to be the same number in opposites immediately. So I would have multiplied like the top one by a -6. And then done. They like to do it piece by piece here. So that's why it kind of looks like a lot more work than it actually is. Okay, so they took this and they just rewrote it here. Cool. That's all they did. This rewritten here. Okay, so from here, our top equation stayed. What happens is that they multiplied this bottom one by a -1. What that did was it flipped all the signs. So we have 12x times -1 is a -12. And 24 times -1 is a -24. That was the focus there, opposites. And then -12 times a -1 is a +12. Okay, what that does is then we can combine them to get those to cancel out. Now, see how it says show method B and circle the coefficients that cancel? Show method F and circle the coefficients that cancel? These are 2 other options. So these right here are just other options that we could have done. I think these are easier ones. So go there, pause the video, show method B, see if you can figure out which coefficients cancel. Show method F, right? There's that giant list of all the methods. There's actually A through F. I think there's a bunch of methods. This one they used a fraction, which, because they simplified. They divided all those by 2 so you could work with 3. Actually, okay, I see where they went with that. Okay, so you're going to fill those in. I'm going to move on because those are, again, options. From there, yes, the key is picking whatever's easier. And that's what you have to pick. Now, for these notes, apparently they did not pick the easier ones. So I don't know why they chose that. So here we go. This is our 54x plus 24y. That's this right here. So here, I'll change my color here to show you. This is just rewritten right here, okay? Just for space. So this whole part right here is options about how to get those coefficients the same. So it'll look much quicker when we do a practice on our own. So our goal is to solve for x. So what we do is we add these 2 equations together. This is the part that kind of seems weird and kind of out of nowhere, but it helps us here. So we have 54x and a -12x, which together 4 minus 2 is 2, 5 minus 1 is 4, so we get 42x. Here is where the whole method is named elimination. 24y minus 24y, those are eliminated. They're gone. Then we have 72 and 12. 2 and 2 is 4. 7 and 1 is 8. From here, we just divide both sides by 42, and we found our x. So a lot of students do like this method because it does actually go quicker if you pick much smaller numbers than that they chose. And x is 2. Once we have that, just like in our substitution method, we take it back, and now you solve for y. So you take that x that we found, substitute it in here for the x. It looks like I put it into the 3. No, in for x. So we have 3 times 2. So 3 times 2. And then we just solve. 3 times 2 is 6, right? So then we subtract 6 from both sides. We are left with 6y equals a negative 9. And we divide both sides by 6, which leaves us with a fraction. So just simplify your fraction. What can 9 and 6 both divide by? 3. So we end up with 3/2, negative 3/2. There we go. This is why we need this method for those fractions and decimals. Lovely. Okay, so let's do this together here. So I'm going to do number 1. Now, our goal is to pick the easiest ones to work with. So I usually pick the smaller numbers. A lot of people like to pick the first ones. Let's see here. 5 and 3 are bigger numbers. 2 and 3 make 6. That's a lot nicer. So let's get rid of our y's here. And I'm going to pick the top one to be negative this time. Why? Because I can. If you struggle with integer rules, take your second equation as a negative. That'll help you with your integer rules. So what I'm going to do here is I'm going to multiply this top one by the whole thing. 2 times a negative 3. That way I get 5x times negative 3 is negative 15x. Okay, and times 3. I don't know why it looks like an x. Maybe put the dot. And then 2y and negative 3 make negative 6y. And 15 times negative 3 is a negative 45. All right, so what we need to do is multiply the second equation by something that will give us a positive 6, so that way the y's can be eliminated. So let's see, we can pick 2, just times 2. I'm going to do the dot this time. Oh, that looks much better. Maybe I'll make this into a dot. Okay, so we have our 3x times 2 is 6x. Notice I'm lining them up. Good. 3 times 2 is a positive 6y. And 9 times 2 is 18. All right, lovely. Now we add them together, right? Like just a giant plus sign here. Negative 15x and negative 6. And a negative 9x. And then 6y and negative 6y are eliminated. Those are gone. That's our whole method, right? Is elimination. And then we have 45 minus 18, and I'm feeling lazy here. 27. Oh, okay, negative 27. From here, we divide by negative 9. Divide by negative 9. We get x equals negative 3. Oh, negative, positive. Positive 3. My bad. Watch out for those integers. All right, so we have our x is equal to 3. Now we can substitute that x into our top equation or the bottom equation. I'm picking the bottom equation. Why? Because those are smaller numbers. 3 and 9 are smaller than 5 and 15. I mean, 2 is fine, but overall. So if we substitute this back in, we have 3 times x, which we just found was 3, plus 3y equals 9. All right, so we have 3 times 3 is 9, plus 3y is equal to 9. When we subtract 9, a lot of students, and especially on that test last time, were putting that 3y is equal to 0, and they'd be like, oh no, 0 means no solution. Calm down. There's still a variable over there. So if there's still a variable, we're good. We just still divide by 3, divide by 3. Oh, look, y is 0. So our answer is 3, 0. Oh, look, it is our answer. I'm going to start you out for number 2 because number 2 here, there, I'll move my face over here. Number 2 is actually easier to get rid of your x's. Why? Look, the 4's are exactly the same. We just have to pick one to multiply by a negative. So I'm going to rewrite our first equation because that one can stay. 4x plus 2y equals negative, that's not a negative, negative 7. And then our second equation, we can just multiply everything by a -1, which just flips our signs around. So that gives us 4x times -1 is a -4x. See how those x's will disappear? Negative times a negative is a positive 6y. And -11 times a -1 is a positive 11. From there, when we add these, whoosh, whoosh, we get 4x and -4x. Those are eliminated. So again, it doesn't matter whether you eliminate the x's first or the y's first. Pick the easier one. Then we have 6 and 2 is 8y is equal to 4. Good. I'm missing a negative somewhere, aren't I? What? All right, we divide by 8, we divide by 8. Oh, nope, I'm not. I see it. Y equals 1/2. Okay, I thought it was supposed to be this -2. X coordinate. Okay, I feel better. So 1/2, and then you substitute your 1/2 in. So let's do that here. I think that top equation is going to be best. So I'm going to do the top one here. So we have 4x plus 2, and our y is 1/2. Equals -7. Okay, so 2 over 1, 2 times 1. That's just going to be 1. So we have 4x plus 1 is equal to -7. We subtract 1, we get 4x equals -8. And when we divide by 4, we get x equals -2. There you go. There's the ordered pair. Right there, our x is -2 and our y is 1/2. Ta-da! Don't get scared with fractions. All right, you're going to try and answer this question. So this is you on your own. We did all the math together. You're going to explain why both multiplying and dividing equations is acceptable when trying to match equations with one another. We did a lot of this. We didn't do this, but explain why that one would work too. All right, see you in class.